Welcome learners for the lecture 19 of a differential geometry. Today we discuss about the second theorem that will be generating for a variable functions p d phi upon ds in a mod is a maximum in the direction orthogonal to the curve phi uv equals to constant through the points p and the angle between minus phi to phi 1 and the orthogonal direction in which phi is the increasing pi by 2. Okay, what is the proof? Let p uv be the any points on a surface. We have shown that phi increase most rapidly at a point p direction orthogonal to the curve passing through the point p. Prove that d phi has the greatest value in such direction. Let Lm be the any direction through the point P on the surface. Let mu be the magnitude of a vector phi equals to minus phi 2 upon into phi 1. Let theta is the angle between L and M. Okay, all will be conditioned discussing. Then after that A equals to L R1 plus M R2 and B equals to minus phi 2 R1 plus R2. Okay, both of these conditions. Then find A cross B expressing sine theta in terms of a h and mu, where mu equals to mod of b from the definition of a mod of a. We have mod of a into b equals to mu sine theta. This is the equation first. Then a cross b considering L phi 2 plus M phi 2 R2 into R2, so that mod of a cross a is generated to the form that is a H L phi 2 plus M phi 2. Okay, this will be considering. Then equation first and second generating mu sin theta equals to H L phi 2 plus M phi 2 will be given. Then Lm are the direction coefficient of the tangent through the point P. You know that L equal to du upon ds and M equals to dv upon ds. Then using to the equation 3 in a 4 and simplify to the value that is a mu sin theta equals to h d phi upon ds. Now mu and h are always positive and do not depend on to the LM because both of these value for the solving to the equation they generated. Then d phi upon ds has a maximum, then sin theta is a maximum. And cases theta equals to pi by 2. In similar manners d phi and ds has a minimum value, then mu upon minus mu upon h is generated to the value, then theta will be generating minus pi by 2. Okay, h is greater than 0, mu is also greater than 0. This position will be given in orthogonal direction, means that d phi upon ds is also greater than. In such cases theta equals to pi by 90 degree will be considering. Hence mod of a d phi upon ds has a maximum in an orthogonal position to the phi uv equals to constant to the value. Okay, next topic is a orthogonal trajectory. You know that the family of a curve on a surface, we are interested in those family which cut each other orthogonally. This leads to the definition of a orthogonal trajectory. Okay, definition will be given. Let phi equals to uv equals to c be the equations of the given family of a curve on the surface r equals to ruv if there exists a second family of a curve phi uv equals to k lying on the surface such that every points of the surface to curve on a one from to each family are orthogonal, then the curves of the second family is called as a orthogonal trajectory in this form. Okay, to given as a theorem first, every family of a curve on a surface possesses a family of a orthogonal trajectory. Okay, proof will be given. Let R equals to RUV be the equations of a surface. Let the given family of a curve is defining form. In this equation, changing to the equation, they get it as a point P and Q for a du and dv in this form. Okay, this is the equation first. Since du upon dv equals to minus q by p, the tangent at any point on a curve has the direction ratio that is a minus q p. Let du dv be the direction ratio of a tangent at a uv of a member in an orthogonal trajectory of a given family. Okay, two direction lambda and mu and the lambda dash mu dash are the orthogonal, then it will be generated as an equation. they changing to the value, you compare to the both of this form of this equation. Okay, r1 into r2 will be generated in this form. Then e lambda lambda dash plus f lambda mu dash plus mu lambda dash plus g mu mu dash equals to 0. Applying this condition of orthogonality to the two directions minus qp and du dv both are obtained. Okay, e minus q du plus f minus q dv plus p dv plus gp dv will be generated, means the equation will be given to the form and they generated as a value, then which simplifies to the form that is a eq minus eq du plus gp minus fq dv will be generated equals to 0. This is the differential equation of the orthogonal trajectories of the given family of the curve. Then since eg minus f square is not equals to 0 and p and q do not vanish simultaneously, so the coefficient